Okay, welcome. Uh, Hello, everyone. Thank you for watching this webinar. This time we will have a really special guest, and I'm really thrilled that we have it, Jarek, with us, because Jarek, currently your official title is Senior Staff Software Engineer, but Jarek is working on Neo4j and he's responsible for performance, benchmarkings, and all that other lies. And
Yeah, a lot of lies.
yeah, plus one of the reasons that we are here is because that thanks to Jarek, I also started my speaking career. So he like placed a seat to be here a few years ago when I first did my conference talk on the talk that Jarek was organizing. So if you're not from Poland, then Jarek is our local hero. So yeah,
It sounds terrible.
I'm flattering Jarek, especially because he doesn't like that. But yeah, Jarek, could you tell us why did you found out that taking care about the performance and being performance engineer is something that you'd like to do? I'm not sure, but for me, that doesn't sound like a first thing that you have in mind when you're starting your engineering career, or maybe you had that since the beginning.
No, I didn't. So it happened by accident, like most of things in life. Yeah, I think it it came to me quite late, but I like it. Like, after maybe 10 or 12 years in my career, but I actually care about performance, and I'm like really into it. Because to be honest, I got bored with like day-to-day coding.
Mm-hmm.
Uh, no, we talked before, but it's like everybody talks that we are working on innovative products and we do like, unique and unusual things, but it's not. I was changing jobs, wait, I not super often, but like every 3 to 4 years. And after some time, I realized actually I'm doing the same stuff over and over again. And I don't, and I had my like, I would say short, but yeah, short adventure with management when I realized this is not for me. But I'm not good with people. So when I came back from my like being manager and chief architect experiment, I said, okay, I don't want to do, management. That's not for me. I don't enjoy it. I don't enjoy it writing repeatable code and pushing JSON back and forth in a different ways. But I still love coding. And then I realized that I'm really like into digging into the systems and understanding how they work. Uh, you know, Going through all the layers strictly to hardware level, and that's funny for me. I know that's weird. People look at it me and say, "Okay, it's not funny. It's super interesting, I think." So yeah, this is why I realized that this is. Mm, I was always looking for something that is not only coding. It's like coding is, I don't know, 20% of your job. Understanding the system is 80% of your work.
Mm-hmm.
Uh, and benchmarking performance requires you to really understand how the system works. Uh, Dig deep into like the silicon, not necessarily understand, writing in assembly code. I don't do it. I can read it, but I don't, I cannot write it. But yeah, I thought, okay, that's fun. Uh, that's the one thing why I moved to it. And the second reason is I at some point of my career, I was like on-site disaster engineer. So basically, every time there was a disaster in a system, somebody called me. I don't know why. Uh, and I was always working and always getting like performance problems. So I think The fate was for me to work on benchmarking, and somebody else tried to show me that I should work on performance because every time I had production issues, it was like related to performance. At some level, it's always performance problem, except when it's security. But funny thing, I once had security issue, which at the end revealed to be a performance problem. But that
Mm,
what happened, we leaked data because of the performance problem. So yeah, this is how I got here.
mm. I
Uh,
thought that you would say that you managed to make your old past system work, then make them right, and now is the time to make them fast.
yes, yes, exactly. Yeah. Uh,
Yeah. Do you think that your past experience, like I would say holistic experience, because you were like chief architect, you were consultant, you were developer, and so you wear a lot of hats. Do you think that it helps you in like working on performance? Because the I think that at least for me the typical stereotype of person interested in the performance is, you know, this geek that went pretty down the rabbit hole, someone with a good mathematical background and really like with a looking just straight into the, as you even mentioned, the silicon, so assembly, etc. So, what are your thoughts on that?
uh, I think it depends on the type of performance test or type of benchmarks you are up to and the kind of performance issues you're up to. So what I'm trying to say is like, okay, if you optimize, I mean, gaming library, yeah, you have gaming engine and you are optimizing something for the like pathfinding algorithm for gaming or some rendering algorithm, then yes, all my experience is useless because it's pure math and silicon and GPU architecture and memory, how memory works and so on and so forth. But if you are like, I would say, systems engineering system performance engineer. So it's not like low-level performance engineer, but system performance engineer. It means you need to understand how system works, that you have different components, that some things are, synchronous, some things are asynchronous in the system. Uh, how databases work, how your runtime works. So, be it JVM or .NET. So I think the more you see, the better performance engineer you are, in my opinion. Uh, if you want to be like system performance engineer, uh, because I think the whole uh, trick with performance testing and performance tuning is to understand how system works. It's like with the car. You need to
Hmm.
pick up, uh, look at the engine and go deeper and deeper. Um, so if you understand, the more layers you understand, the better for you. Mm, because I love this. I don't know, I don't remember the title of this blog post, but there are like 7 or 10, something like 7 or 10 deadly sins of performance engineer. And one of the things is mm, beware of dark spots. So
Hmm.
basically, the most dangerous things in your work is the things you don't know. You don't know. Because when you make assumptions that, the database works this way, or indexes work this way, or, Kafka works this way, and you make an assumption, and in most cases, your assumption is wrong and you make some, performance decisions or suggestions to improve things based on false assumptions. So yeah, I think like the vast experience on different layers, architecture, being architect, coder, and what's important, I think, kind of sysops person. So understanding the operating system and hardware layer really helps.
Hmm. Yeah, so I I agree with your perspective. I'm wondering, because you already mentioned that that there are multiple layers that we can look on the performance, and my guess is that each time someone tell us something about performance, then quite often those people mean something different. And what I noticed, it's like one of those blocking discussion phrases, like will it scale? Will it be performant? So, from your perspective, what are those different types of looking at performance, or how what different types of performance testing do you see? Like, how can we maybe make our and I mean our in general discussion about performance better?
Um, so I think like well, this will be fun. Uh, it all depends. It's like if you execute. Oh, let's go this way. If you run performance tests, you have a performance scenario, and you are running performance test. I think the most important thing is to answer this question: what you want to get from it, what kind of answer you are looking for. Because in most cases, what you are looking for is, the latency or throughput. So this is like kind of load test when you have you select specific load level, 500 concurrent users, and then you look at some latency numbers or throughput numbers. So this is one layer. And I think it's the most often used layer and this is what you see when somebody, endorsing their product is, our database handles X queries per second, X thousand million queries per second. I love these numbers. And then people make decisions based on this, on a single number. That's one thing. Another thing is you can run the same performance test for a long time, and they are sometimes called endurance test.
Mhm.
When you execute your performance test not for an hour or 2 hours, but you run the load for a long time. And then in this test of case, you are not looking for like latency or throughput numbers, but you look for performance degradations over time. For example, because when you run system under heavy load for a long time, you can start seeing like lovely small tiny memory leaks that don't show up during in 1 hour or 2 hours. You can see, connection pools being exhausted, and because you don't return back connections or resources back to the pool. So then, it can be the same scenario, but with different parameters, like runtime. You can say, okay, I'm not looking for the performance numbers, but I'm looking for, the regression over time. And then what's endurance test? Then you can take a look, okay, I want to see the scaling tests. So I run the same scenario with different users and see because every system has a limit of at which it can run faster. At some point, the thing will flutter. Yeah, you will have a flat line. It comes back to the queuing theory, of course. Uh, and of course, AMDA law and universal scalability law. So then you run the same scenario with different number of users to see, okay, how we scale, where is the limit? Because if you run with different, you will have multiple data points. You can, approximate where is the end of your system. So then you have scaling tests. Uh, you can have, but I never did it, like you run your performance tests like in microservices environment and you shut down one of the components. Yeah. You do like what will happen, how the shutdown of your one of microservice will impact your performance. I never did it, but if you look at books about performance, this is one of ways of looking at it. So basically, it's scaling, it's load test, it's endurance test, when you have like disaster, kind of disaster recovery test. Uh, but these are all like system level tests. So what you do, you need to like start a copy of your environment, the database with services, with endpoints, and so on. And then you have the lowest possible way, level of tests. We call it benchmarks or micro benchmarks. When you don't start the whole system, and what you do during the test, you exercise like single function. It's like I like to compare unit test and benchmarks. Like, benchmarks are
Yeah.
the level of the smallest unit. Yeah? So the performance test, end-to-end test with different flavors, and then you have benchmarks.
Hmm. Uh, I think that I even saw that on one of your talks that you said that we have sometimes the culture of benchmarketing. So there are many companies that are just, giving a lot of numbers and just bragging about it.
Yeah, so benchmarking, I learned it when I joined Neo4j. I learned about benchmarking. And our general strategy is we avoid playing the numbers game. So
Hmm.
it's pretty hard to find our benchmarking numbers. Uh, we do a lot of benchmarking. You have like full-time 6 people working on it all the time.
Hmm.
This is not our side job. We are like 7 hours, 8 hours a day, uh, excluding lunch benchmarking stuff. But the marketing game with numbers, I saw so many cases where, how often, what's it like? I really like to ask this question. If you have, with some company publishes some numbers about their product, how often they share the code they use to do the benchmarks?
Yeah.
Because, give me any number and I can design a benchmark to, satisfy this number.
Yeah,
So,
there are those. I think they are called like tech empowering benchmarks, which are comparing different tech stacks like .NET, Java, etc. And they are actually showing their code. And if you look at the code, then it's just total bullshit code because it's no one writes the code in this way. So even in Fiore, they are checking like the ASP.NET or Spring or any other web framework. So in theory, they should give you like end-to-end benchmarks, not micro benchmarking. Then
mhm,
the way they are coded and the tricks those providers are using to show that their tech stack is fast is it's incredible.
yeah. Yeah,
But
I think the only kind of organization I trust is Spec. I don't remember the name. It's Spec, Benchmark Spec or something. I will find this name of organization. So versus like what they do is they compare hardware, like,
mhm,
different CPUs, and then they compare, for example, JVM versus .NET. Uh, and this is like third-party organization. So I have more trust with like third-party testing benchmark
mhm,
tests providers, and they share everything from code to the specification of the infrastructure they run the test. So yeah, you can write any number and design benchmark to prove that you are right.
mhm. Yeah, I agree. Like when I was working at Event Store and I wasn't responsible for from benchmarks, I was mostly part of the discussion on that because I was working on this weird title of developer advocate, and the people were asking me constantly like, give me the numbers, how many requests can you handle? And when I was asking them like, okay, but what are your application characteristics, then they rarely were able to give me their numbers about the
Mhm.
sizes of their boxes, etc. And as you mentioned, in Event Store DB, we also had the set of internal benchmarking, but the intention was that in theory, we could show those benchmarks. They weren't so bad, uh, but they just wouldn't give people any meaningful information because they were really raw and focus on the specific use cases, etc. And they were more used to detect the performance degradation, etc., rather than focus on the specific numbers. So maybe could you share some insights of how you're dealing with that in Neon4j? So what is your like main driver and how are you finding your ways, which types of tests, and you already mentioned a few, to use for which use cases?
Yeah. So basically, what I said, we don't play benchmarking game. At least we try not to play this game, but we have a really heavy suite of tests. And uh, and what we do, which is like super interesting, it was like surprise to me when I joined, is we test the product on different layers. Because the problem with finding regressions is when you run the whole system, there's so many things happening, you know, in different threads, and it's really and different parts of the code, but it's really really hard to find um, the problematic code. So what we do is of course, we have micro benchmarks, and they are mostly used in most cases for like bottleneck finding and optimization. So we use benchmarks and micro benchmarks because we use JMH library for Java. It's like we use in most cases micro benchmark to guide our optimizations because somehow when you like want to optimize the code, you need to have like really focused benchmark showing,
Mm-hmm.
okay, I'm exercising this function with this parameters, this output. Uh, so you need really repeatable benchmark, and that's one. And the second thing is you don't want like another processes disturbing you from finding. So this is one layer. This is the benchmark. And what is interesting then, because it's a benchmark, we don't start the server, the database server. We just run, for example, benchmark for specific operators in database.
Mm-hmm.
So if you have a query is turned into a query plan. The query plan is, then executed. It's like the simplest possible explanation of how databases work in 5 seconds. And the query plan is turned into tree, and the tree is the tree of operators. And one thing we do, we test these simple operators. Like, you have operators for
Mm-hmm.
sorting. So we just test sorting. Because we are a graph database, we have an operator that do some kind of traversing of the graph. So we have benchmarks just for traversing. Then you have aggregations, the queries, you have predicates in the queries. So we have like micro benchmarks for all these kinds of operations.
So,
Uh,
sorry for
yeah.
interrupting, but so does that also mean that you also need to have like a code that is aware that it can be benchmarked? Because as
Mhm.
you said, if database was a monolith and you wouldn't be able to just check the traversal in a meaningful way, then it would be hard, right? Or almost impossible to get
Yeah.
meaningful information.
So this is kind of this thing is side effect of how the query execution works. And the query execution models, like, the volcano model, the iterator model, they all have this concept of simple small functions. So I think we haven't thought about making like benchmarking ready because it was the side effect of the writing database. Because every query at the end is there just collection of small functions,
Mm-hmm.
composition, aggregation, whatever you call it, of small functions. So for database, at this level, it's easier because you can isolate specific operations. But I imagine if you do something else, you need to write your code, but in a way that mm, that okay, you can test specific functionality in isolation. You don't need to start the whole thing. So yes, uh, if you follow the good practices and you like have the composable code and you do the proper separation, you will be able to benchmark it. I know TDD is on the fall right now. It's people like saying it's crap and doesn't work. I'm just waiting for revival of TDD in next 2, 3 years. We need to we need to have something to talk at conferences. But it's like the same with TDD. It's easier to test something that is encapsulated, have stable interface and doesn't have a lot of dependencies. So if your code is stable, it also means you can write benchmarks for it. If your code isn't stable and you are not able to write tests for it, probably you will be not able to write, benchmarks for it.
Yep.
So yeah, that's if you want to do benchmarking like at the level of functions, you need to think about it, how you organize your code.
Okay, so benchmarking. So what's the next level of
Next
testing
level
that you
is we
do?
start the database. Okay, so this is like next level, and this is our like more end-to-end performance test where we actually start the database, load it with specific data. So we have things called datasets and workloads, where we have sometimes artificially generated data because we want to test some specific scenario. Sometimes these are things inspired by internet and our use cases because we say we work. These are the use cases for our database, like for example, fraud detection. So we have a data set that emulates fraud detection. Or for example, recommendations. So we have people quite often use graph databases for recommendations. So we have a data set with products and customers. And on top of these data sets, we have queries. This is end to end. So we send queries to database. But what's really interesting, we do it from single thread still. Why? Because um, it's easier to find problems. Because I really like what we do because we are really focused on not necessarily numbers, but how we can quickly find the problem and how quickly we can optimize our code. So the numbers are interesting. We use it at some point of time, but we are more interested in, okay, getting enough information to be able to optimize code or find regression.
So does that mean that you're more focused on the trends rather than the specific results?
That's true. We are looking at trends. So this is like we run from a single thread. So it's still when you run profiler with it, profile this code, it's easier to find problems. And yeah, we run it from a single thread with different parameters. And we have, I don't know, around 30 data sets. Every data set has like around 10 queries, different type of queries. So you can imagine it's like quite solid number of possible scenarios. Then if you, what's really like, this is when I'm suffering right now, is like on one side we have 30 data sets, every data set has 10 queries. So it gives you like 300, for example, possible scenarios we can test our database. But then you start adding dimensions, this JVM version, this product flag switched on, switched off, or this Linux, or this cloud provider. And then you have like explosion of possible parameters and combinations. So this is like part of our work to say, okay, which parameter combinations are the right one? Yeah, you could run everything, but it will cost you millions. So this is like one layer we have.
Uh,
Uh,
can I ask about this single threaded? So is it like you are running database in the single threaded mode or
No, the
just
database
at
is
the test?
multi-threaded, but the load generator,
Mm,
the
okay.
client of the database is single-threaded.
So would it be like the always a single scenario is run in the single threaded
Mhm.
mode?
Yeah, yeah.
Yeah.
With different parameters, but like if you have a query and the query has parameters, we iterate over different parameters, but it's the same query over and over again.
Mm-hmm.
So we don't then face some, caching issues and code warm-up issues. It's like when it's fast, we see like optimal performance of a specific query.
Mm-hmm.
Then it's easier to optimize for this optimal performance of specific query.
Mm-hmm. Okay, so you're ensuring that the database is warmed up, so it has,
Mhm.
as you
Yeah,
mentioned, the caches, etc. Yeah,
yeah.
so uh, that's I think one of the trickiest that people don't realize is that because on one hand, if you have this warmed up database with all the caches, everything best in fitting in memory, if possible, etc., then that gives you a good measurement of what you can achieve. But then some people are saying, yeah, but my database won't be always warmed up. So I would like to test like the real world scenario. So that's what many people I think are struggling. So do you also verify those use cases where, like, let's say either edge cases or rough real world use cases?
So yeah, for this we have like two separate type of tests. We call it load test. And
Mm-hmm.
this is the scenario when we have like, multiple threads, multiple concurrent users. The database probably doesn't fit into memory.
Yeah.
Uh, and this is like more customer focus for customer facing benchmarks because they like exercise the real world scenarios where we have many users, we have, locking going on all the time. The database doesn't fit on the memory, so you need to reach out to disk and, when the block manager or page cache, performance or the eviction algorithms, if they are like optimized for this scenario. So we have like the last layer, it's load test, and then we have something called LDBC. It's Link Database Council. So basically, this is standardized benchmark for graph databases. Like
Mm.
in relational world, you have TPC.
TPC. TPC.
In the graph databases world, you have LDBC, where you have really what we use is a social network benchmark. It basically simulates Facebook. So you have
Mm-hmm.
users, you have forums that inform you, have messages, then you have links between users. The forums and messages form a tree of threads and so on, and they are like heavy queries and different. What's like LDBC on one point? Um, okay, I cannot say it. Express my personal opinion about LDBC, but one interesting thing about LDBC is, uh, and this is like a lesson from designing benchmarks, that they have different types of queries. Because in the database world, you on one side you have a tons of something called short queries. So basically a query that touches one database, I mean one table, or touches one node in the graph, or touches only one document in a collection in MongoDB. Yeah. So short queries you do, index search, filter by
Yeah.
values, you're done. And most of your traffic looks like this. And and LDBC is designed in a way that on one side we have a bunch of different defined LDBC, different queries that are short reads, and they are quite often from multiple threads. And then from time to time, we have like a monster coming, select star from table. So there are queries that touch bigger parts of the database, requires a lot of traversal of joins, and they don't run so often, but they run from time to time. just to enforce loading some data from disk if it doesn't fit into the memory. And then you have, of course, write queries and update and delete queries in the meantime, changing stuff. So yeah, I wouldn't, in my personal opinion, never ever design such a workload. I would use existing workloads like TPC or LDBC because you get into territory of okay, how we emulate the real world.
Yeah.
Either you record traffic, which I strongly recommend. Don't don't get into this game of designing your own workload because there are so many things happening and there's like thread interleaving and queries interleaving because you have concurrent users. But probably if you are not PhD, you will not design the proper workload. Like I mean, with mixed queries and different types of users. So yeah, I think if you want to design something what looks like a real world and you can do it, record the traffic and replicate it. That's the best. Unless you are looking for like specific scenario or you are adding a new feature to a product that is not covered. Then you have to sit down and think, okay, what kind of data input I need to prepare for the benchmark. But if you have existing system, just record it and replay. So yeah, this is what we have at the moment. So
So am I correct that it's the harder, like as you were talking, like benchmarks, those latency throughput tests, and then load tests, then with each of this layer, it's harder and harder to get them right. And by right, I mean repeatable or meaningful, because I mean, even for benchmarks, I tried a few times to create a repeatable benchmarks and I wasn't able because, for instance, on my local notebook, there are other applications. Even if I think that I kill all of them, then system are doing crazy stuff sometimes. And I was always getting hard time to get those results on GitHub Actions. Some people believe that we can measure the trends, as you said, but then it appears that those GitHub Actions are heavily reused containers of some VMs that and other people are running them in parallel, and getting those is enough hard. And then if we are getting this load test or endurance test that you mentioned, then my guess is that nowadays, like in cloud, it's super hard to even know whether you have this isolated traffic, isolated network, isolated disks, etc. And my guess is that all of that has an impact. Do you have some thoughts or guidance how to deal with that stuff, or maybe I'm just totally wrong
you're
here?
right. So, the like repeatability. Oh, I don't know how to say it in English.
Repeatability.
Repeatability of benchmarks. So basically, I think if you have benchmark that doesn't have repeatable results, like basically you can measure because you measure, the standard deviation or you
Mm-hmm.
measure coefficient of variance, you get into the statistics land and you find a number that will tell you if your results are stable. If you don't have stable results, it's better to throw away this benchmark
Mm-hmm.
because it will just create noise in your day-to-day work. Because sometimes it will be fast, so you'll be excited, and then you will be slow. You will start seeking the problem, and then you realize you are running on different machine or with different data set, and you lost a couple of days. So it's really important, and part of the thing, like with our team, is like sometime I think once a month we go and look at queries but they're not stable. I mean, not stable meaning don't have repeatable results, and uh, and try to like design the query better or provide better parameters for the query. But yeah, in cloud environment, it's super hard. One thing, what you said, GitHub Actions, no, because you don't know where it's run.
Hmm.
It's like, forget about it. Yeah. Your laptop, you have some control over it, but not full control. So what we do, for example, in AWS, we just use EC2 instances. Uh, and of course, that's funny thing. We start the EC2 instances every time. So we don't have like all time running EC2 instances. It's before every benchmark, we go for this quite expensive but worth the effort thing. But we start when we trigger benchmark, we start the machine and we set up the machine from scratch. So always come clean, always. You know,
Hmm.
reinstall JVM, reinstall necessary dependencies. Like we use a lot of profiling tooling around it. Uh, Start the clean database from scratch, empty directory, you know. So that's one thing. Another thing is, especially for database, you care about stable storage. And there are ways to provide kind of stable storage. You either select NVMe drives and you say, okay, I don't share with it anybody. I have like fast NVMe drives that are not shared with everybody. So you can trust the numbers as long as you trust cloud providers, of course.
Hmm.
Uh, and then if we use EBS, for example, we use provisioned IOPS. So we say, okay, we expect this amount of IO operations. Because it's quite easy to have stable CPU performance and throughput in cloud. If your, I would say if your benchmark don't touch storage, you can get quite good, stability of especially at the higher end type of instances,
Hmm.
like 4, 6, 8 cores, anything beyond 4, in my opinion. This is not proven. It's like just gut feeling what after 6 years in Neo. But the stronger instance you get, the more stability you get in the performance numbers. So for CPU, if your benchmark doesn't do I/O networking, uh, yeah, EC2 can be quite stable. If you go into the networking I/O land, you need to like pay extra
Hmm.
and get like provisioned storage, provisioned IOPS, sorry, or some network with some, kind of guarantees. So it's we spend some time to finding the right instance types. So one that's interesting story. Like 2 years ago, we were migrating from on-premise benchmark infrastructure. So we had some servers, we bought some hardware, and we were running on bare metal machines. And then we decided, okay, the operational costs are quite high. We need to keep, the versions of the operating system up to date and all the not so funny stuff. So we said, okay, let's run this benchmark in the cloud and see how stable they are. It took us 6 or 7 months experimenting with different instance types with different storage until we are not looking to get the same performance numbers because we don't care.
Yeah.
We care more about trends. We are looking for the combination of storage, CPU, and memory that will give us the most stable results. So you need to spend some time trying different instance types and instance families. For example, if you are in AWS, like, should I run on M family, which is compute optimized, or should I use L
Hmm.
family, which is memory optimized? And select the right combination, and you can get quite stable results.
Hmm.
But I think the stability of your results is it's worth it. Because then if something blows up, you don't spend time looking, okay, maybe this was wrong machine type, or maybe I ran on something that was running backup at the same time. So, and of course, you want to plane system as much as you can. So no, like, special security, crawlers or
Hmm.
automatic backup things. So you plain vanilla Linux if you are running on Linux with nothing extra except your system. Yeah.
Hmm. Yeah, so if I would need to reiterate, then definitely mm, ensuring the VM types. So, and comparing that with the type of task that we are doing. So, as you said, either it's more about memory or is it more about the CPU? If we're just doing benchmarking, then EC2 should be fine. By just benchmarking, I mean, as you said, no IO, no networking.
Mhm.
And if we need to have networking and IO, then we need to either accept that our benchmarks will have the higher threshold or need to pay more for dedicated instances.
Yeah, yeah.
Yeah, because we, for instance, uh, yeah, it I think that it also requires to knowing a lot about the pricing and these weird tricks that cloud providers are giving to us. Like for instance, I was one uh, doing the performance analysis. I wouldn't even say that it was a proper load testing, etc., but just getting more or less understanding how fast will be my streaming solution. I was streaming big files through the network, and then I wasn't able getting a proper resources because in the end it appeared that someone in the company connected to this VPC network because they thought, okay, this is already created, so why don't I reuse it? And because I was streaming a lot of data, then it was the results were really vulnerable. It's
Mhm.
I I mean I knew that there is no magic. It's still some network connection between one computer and another, but we tend to believe that if it's cloud, then it will automatically magically scale or be isolated. And I quickly learned
No.
that's not the hard
It will
truth.
scale and it will be isolated only if you pay for it.
Yeah, exactly. Or I was once testing my database solution and I selected some instance that it seemed that it was fine, but then it appeared that it was like the CPU was 20% of the
Mhm.
usage, memory was higher, so it was looking nice, but then it appeared that this database had the network limitations. So if I wanted to check more connections and more activity, then I would need to pay more to get the higher network throughput. So there are a lot of things. I think these tricky parts in the cloud setup that.
So we had this situation with S3 some time ago when we were testing some backup and restore things on our database side. And what happens is in the beginning, S3 gives you all the throughput you have, but if you copy something for too long, it slowly degrades the performance.
Mm,
So I think that's one thing that I'm surprised people are ignoring, that if you do run benchmark or if you do performance test, run metrics. Yeah, everybody is talking about observability.
mhm,
So if you do performance test, do observability at the same time as well. Because once you get the number, I tell you, 200 milliseconds, is it fast or slow? It's like,
yeah.
it's depends, yeah? So it's really important to run your CPU metrics and IO and all the things you can collect because when you get the number is the tip of the iceberg. It's just an indication, okay, you spent 200 milliseconds on this. But then how much 200 of this 200 millisecond was actually doing work and how much of this 200 millisecond was waiting? Because I think this is what I realized a year ago. It took me like 20 something. But most of the time, what our computers are doing are waiting.
Mhm,
It's not that our code is slow. They are just waiting. They could run faster in under one condition. They would have the data they need. Because most of the time, our systems just wait for the data from network, from memory, from disk. So so watch the metrics because if you see 200 milliseconds and then you see that your CPU is like, for example, like you say 10% of CPU. This is the case I had recently. Somebody asked me to look at their system. Uh, I cannot share exactly what it was, but it was super interesting. So the application was rendering. It was first time I was like optimizing UI in my life. It was like 3 weeks ago. So I didn't know how to approach it because I do databases. Uh, and the rendering of some things on the UI was taking so long. And they said, okay, that's the problem with the code, and they wanted to me to look at it. What we found, long story short, what we found, this the rendering was slow, not because the algorithm was slow, but it was because it was doing it in one thread.
Mm.
So we saw just looking during the performance test of the metrics, but we were like hitting system with a lot of requests. To render something on the screen, and at the same time, CPU was at the level of 15%.
Mm.
So, like number is interesting, but also looking at metrics can tell you where's the problem.
Yeah.
Uh, so it's really, really important if you run benchmarks, whatever kind of benchmarks, have some profiling and metrics behind it, because numbers are not the goal. I mean, we use numbers to do regressions, and we have some regression detection algorithms, and we like every week we have a list of probably regressed things because it's always probably. Sometimes regressions are expected. So we use the numbers, as you said, as a trend to see if there is regression or speed up when we celebrate. Uh, but we run, I think this is like quite unique, in my opinion. That's why I enjoy it working here. Is we use benchmarks to collect metrics and to collect performance. I mean the
Mm.
file
Yeah.
recordings. That's the value of benchmarks because you then understand the system.
Hmm. Yeah, so you are not like many. I saw that many performance freaks are saying, no, don't use the open telemetry, don't use because it will be slowing down your applications,
Bullshit.
etc.
I'm sorry. I have to. It's one huge total bullshit. First of all, you will run with telemetry in production.
Yeah.
So one thing. Uh, and of course, what we do is if you are aware that some tool has an overhead and impacts your benchmarks, what we do is we run the measurement benchmark and then we do profiling benchmark. So we do one run of benchmarking without tools just to get the
Mhm.
numbers.
So
And
just
then we
something
do,
like a baseline for the
yeah,
other.
yeah. And then, so this is like without profiling, without telemetry, we just run to see raw results. And then we do another run with profiling enabled, in Java world, the async profiler is the king of profiling tools. So we run with async profiler, uh, every tribe of programmers has their favorite tools to profile. Java has async profiler. Mm, and then we run with perf for Linux or eBPF, which is like the latest craziest thing in the performance world. So you can have a runs dedicated just to measures thing, and then you have runs dedicated to do profiling and metrics. But you know, oh sorry, it's like if you run your benchmarks and you don't measure your system at the same time, it's pointless.
Mhm.
Basically. Because at the end, you get the number. And how would you know where to optimize, or maybe if you should optimize?
Mhm.
Maybe 200 is really the max you can get. And then you spend, time optimizing code that couldn't be optimized because this is maximum you can get.
Mhm. Um, so let's say that I have a more or less idea like what is my issue and what I would like to measure, let's say. And then I would like to like get those numbers. So there are some tools that can give you information out of the box. Like you mentioned, like eBPF, or there are some tools that you in theory plug into your system pipeline, or even with the telemetry that you have this auto instrumentation.
Mhm.
But there are also people that are suggesting that you also always should need to have your own manual instrumentation, or some fine tuning depending on your needs. So if someone is starting and want to get an understanding, let's say, why is it so slow, this famous phrase, then how would you approach that from the real tooling perspective? Like
Mhm.
what would be the order of adding tools to start to get at least gradually those information?
So I really like this. This is pretty old article about how to solve the performance problems. That was like saying, okay, you need to look at the performance problem as a box with layers, and the top layers is users. Then you have the application, then you have your runtime, so JVM, .NET, Python, Ruby, JavaScript, and then at the end you have operating system slash hardware. Uh, so basically, you need to define metrics at each of these layers you are
Mhm.
interested in. For example, the users layer. So you monitor how many users you have, yeah, basically. Of course, it's also worth to segment users by like heavy users, but I don't know. I have a case where ages ago when some user was sending, like usually we were getting 1 MB JSONs, and this one user was sending 100 MB JSONs always because of some internal procedures. So you need to also not only by traffic, but like the size of the request and type of the request. But you need to understand your users. And measure your users at the beginning. That's the one thing. Then you have your application, and then you need to decide what is important at the application level. At the application level, probably if you have API, your endpoint response times are interesting. Then you need to take a look for all the things like pooling. What pooling is a source of all evil. It's so good, but it's also source of all evil. So pool sizes and thread pools and connection pools. Uh, and then you go to your manage runtime layer. So, in case of JVM, you look at the garbage collector, you look at the JIT compilation, look at the safe pointing. And then at the operating system, you look at IOPS, CPU, so time spent on CPU, time spent in on IO operations, and contention time, when you measure things like instructions per cycle to find, for example, that you have problems with memory. So, and it's all really well defined. If you go to like low, you just go and read everything Brendan Gregg. It's my personal hero. So everything that Brendan Gregg wrote about performance and monitoring is about how and what to look for when you are observing the system. So like his book, The System's Performance, is like, okay, if you start with, you have no prior experience with performance tests. I think systems design, system performance by Brendan Gregg is the best thing to start with, because will understand what you need on each layer to look for. And he has on his website really nice diagrams saying, okay, if you have application and this application does this, you need to have and measure these things. If you are measuring operating system, and even it names specific tools to use to capture specific metrics. Uh, so you need to watch to all layers. That's one thing. But these are just metrics, so you have like specific data points. Another thing is really mm, be a friend with the profiling tools. No, I know. Overhead of the profiling. Yes. But I always have this discussion about, oh, but profilers have overhead. I mean, yes, they have overhead, but at the end, you are without data or with data. Which thing select? Having the data and understanding what system does, or not having overhead but don't have data? I would say,
Yeah, I would also add that people quite often don't realize how it is important to have, as you said, like having this starting point. So for instance, for database, it means every cached field, every database warmed up, or if we are doing, let's say, maybe, I don't know, like serverless, then ensuring that we are not randomly hitting the cold start if you're doing
mm,
some load testing.
in Java, when you
And
start, it takes time to reach to peak performance with Java. It's like
yeah,
kind of pain point in JVM, but you need to warm up the code to get to
exactly.
optimal.
And those tools can do that. They
Yeah.
just have a lot of statistical knowledge built in place. I'm always, when I'm seeing like someone trying to do like a serious load testing or benchmarking with for each, then I'm like, really?
No, 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 no. Especially in like it, it can work kind of for compiled languages, like C++,
Hmm.
Rust, or C. But for example, if you have uh, Java, JavaScript, Python, uh,
.NET.
.NET, and you have, just-in-time compiler, and your code is modified and recompiled during and is optimized as you run the code. Your runtime is optimizing your code. So it means, people don't realize that, for example, Java starts to optimize the code by default after 10,000 of executions. So you need to run something at least 10,000 times.
Hmm.
And I then see a loop with like, E equals 100. And I say, okay, you don't measure your peak performance, you measure your warm-up.
Hmm.
You don't measure the peak performance of the code. So yeah, there are tools, and it's really, you can spend ages in writing your own, but why? I don't know. I don't see a reason. And don't be afraid, profilers. We run benchmarks together with profile. So as we run and execute benchmarks, we run profilers with them, because then we have lovely charts which
Hmm.
map where we spend time. And overhead is like at the moment, most of the tools around 1.5%. It depends what is your, of course, overhead can get to 10% if you enable all features and sampling, every nanosecond. Uh, so you need to, so what's important is to understand how profiler works. Is it sampling or maybe it's instrumented profilers? How often I take samples? Uh, that's why I love this thing, because you need to really, like, I feel like Dexter from the Dexter laboratory. You need to really understand the things before you start to use it. If you want to play with, for example, profilers, choose your profiler and understand how it works. Because
Yeah.
if you understand how it works, even if it gives you some overhead, you are aware of this overhead. Or like sometimes, profilers lie because of the way they work. And if you are aware that they lie and what they show you is probably something that happened, but not necessarily the thing that happened, it's probably. It's
Mhm.
like, quantum physics. The profilers is kind of quantum physics. If you see it, it doesn't mean it happened. And the otherwise, if you don't see it, it doesn't mean it didn't happen. So if you understand the profilers, how they work, then you will be like better at reading and what you see. You will not get into panic mode that, oh, it shouldn't happen. Um, so that's I think a fun part, and also I think it can be terrifying part of doing performance. But you need to have this like childish curiosity to say, okay, why it happened, why CPU works this way, or why profiler? Because without it, if you even look at the metrics and numbers, you can have a false decisions, assumptions, because there is like too many factors that can impact performance.
Yeah, so so I think that as long as we are not playing this benchmarking game, but we are more into the trends, as we
Yeah,
mentioned a few times, then having a stable overhead shouldn't be like a big deal,
yeah,
because then it's like you are comparing numbers to numbers and not bragging that your requests are so fast and etc.
yeah.
Uh, I have a
Especially where when you do like, networking IO during
mhm,
your benchmarks. Yeah.
mhm. And I have a question, because you even mentioned that you need to understand the traffic characteristic, the use cases, the data set you are working with. But so that sounds to me like more high level understanding and of what your system is doing. Um, but then, if you look on the performance articles, talks, etc., then what you see are mostly like, all those weird, uh, purely technical metrics. At least that's what is put in front.
Mhm.
And I'm not sure if that's correct, but my guess is that's quite often the case why people are scared of doing that. Because if they see only those metrics and they don't have prior experience with that, then they cannot correlate. Like, as you even said, like, if this is 2 milliseconds, okay, this is just for me the number. Is it good or bad? Or my CPU is 20%, then for instance, someone can say like, okay, that's great because I'm not pushing it to limit, but it can also mean that you just bought too big box and you are
Mhm.
overpaying for your instance size, because it shouldn't be, you are just paying 4 times bigger than in theory you should. So uh, i- do you think that it should be like that, or maybe how to approach that reasonably without being immediately scared? At some point, my guess is that you should be scared, as you say, because those lies, etc. But maybe how to not run away immediately after seeing that.
I would say don't uh, don't take these numbers personally. If you run benchmark, if you write your first benchmark, or if you run your first performance test in JMeter, Gatling, whatever you use, and if you see some number, just breathe in, breathe out, and write this number down. So what we do is every time we run benchmark, we write it to the database. We have a database with 5 years of history of benchmarks.
Mm.
So that's one important thing, is record everything. So we write down the results of our benchmark together with the metrics. So every time you can go back 2 years back and say, okay, what happened? It never happens because people care about what happened 2 weeks ago, but we keep, just for fun, 5 years of data. But write down this number and don't care about it. It's like it's your baseline. What you want to do is not make it slower. So next time you run it and you see the same number, well, that's fine. If you see worse number, that means you have a problem, but you don't care about this number in the beginning. It's just a number. This is my baseline. This is my reference point. And then that's the first step. Then you start running with these tools like profilers, or with uh, um, uh, no telemetry observability tools. And we have this kind of interesting ceremony every week that teams gather. They look at not us, but the authors of the code.
Mhm.
They go and look at the profiler recordings, saying, okay, what we can optimize in it. So we don't go like, okay, let's find the problem, because we don't know if it's the problem. It's 1 second per request. We are fine with it. But we start this thing that, okay, we start to look. uh, I think this is the part of the problems. When we look at the performance problems, when they appear, so usually too late. Your infrastructure is down, you're losing money. The only thing what you want is just, bring this system back to life. But if you say, okay, once a month we are looking at the recordings and we are looking for places in the code we can optimize, when you start to optimize this code, run the benchmarks. If you see that your number is lower, it means you optimize the code. So it's like record the number, don't care about it, make sure that things don't get worse. In the background, start the process of iterating over performance,
Mm-hmm.
like you iterate over product. It's the same. I think that's the I try to like force people to think of performance, how like I think the easiest way to convince people to do something is to say that it's not different from what they already know.
Mm-hmm.
Performance is not different from you already know. You have a product, you have backlog of things, PMs, product owners are shuffling, features, and at the same time, you don't care about performance. What happens if you, from time to time, look at the profiling recordings, look at the benchmarks, or look at the metrics and say, okay, this piece of code could have a better query. We could write a better query to optimize the code. Or we can have, oh, this algorithm could be run multi-threaded. We don't need to do it in a single thread. Or we can use better library for, sorting or parsing JSONs. But you should only care about things that give you improvement. Like in the product, you should only implement the features that give you improvement. How you know if something will give you improvement? If you look at the profile recordings and metrics. So if you treat performance problems as, features and iterate over and over and over again, I know it's hard because, the features, this is what counts for business. But if you like once a month say, okay, we found this query is slow, we need indexes on database, or this query is slow, we can write this query a different way. And then you have a safety net because you run benchmarks weekly, for example, and you know if it goes down, you didn't improve the process, but it's fine. So, start running, don't don't think about this number, but use it for regressions and then start looking at the metrics.
Mm.
Should be good.
Yeah, yeah. That's a nice way of looking at things and gradually learning. Still, when, for instance, each time I'm trying to understand those flame graphs, then I then I realize that I don't have any idea how to configure them correctly to start looking meaningful to me. Like I usually getting too much noise in those, and it's hard for me to find. The exact place that my application is responsible for.
Yeah, that's why you need some kind of isolated benchmarks, but like we do, when
Mm-hmm.
we have like single query or the same request over and over again, because then you don't have noise from other people doing other things.
Mm-hmm.
Because yeah, flame graphs from the production systems, unless there is no disaster, they look like noise.
Yeah.
Unless there is disaster that everybody is like touched by, like, exploding database connections. And then you see single stack frame, you
Mm-hmm.
know, occupying all the space. That's why you need this, isolated benchmarks.
Mm. So do you think that or because I like the your suggestion that we don't need to immediately understand what are those numbers unless because if we try to use them as a comparison, then we can still get the value from that. But let's say that someone would like to understand a bit more what's happening behind the scenes and then cry a lot. But so do you think that you need to learn a lot about the statistics and how systems internally work? How deep do you need to go down the rabbit hole, or what are the steps you would suggest for like a regular Joe like me, or
Mhm.
regular Oscar like me?
Regular Oscar. Not regular Oscar, you're doing a lot of stuff. So, uh, I think, like, I like this mixture of, books and hands-on experience. Because books, I usually read books after I understand how things work because they help me like to make my knowledge, in shelves and put it in place. Uh, so for sure, make your friends with the hardware a little bit. Like, uh, don't go to Intel or ARM specific. Don't go into this crazy discussion if Intel Skylake versus or Intel, whatever like they have edition has this specific pipeline for this specific operation. No, you're in the cloud, mostly. So these things are not so important for you because you're on the shared system. But understand how modern CPUs work, how much they rely on caching and caches, how the caches are important part of the CPU. So there is like you don't have to go super deep, but understand, that the cores, for example, are interconnected, and there is a lane that connects all the cores, and the cores in the CPU can talk to each other, and then there are caches, different layers of caches. Uh, so it's the same for memory, the same for disks. Like basic understanding, for example, you will be amazed that queues are everywhere, everywhere. And understanding the queues and understanding queuing is the crucial to understanding performance. So
Yeah.
you're like, first year of queuing theory is like first semester should be enough.
Yeah, so
Uh,
I'm happy that you're saying that because in the previous editions, like the written editions by me, I'm showing different use cases based on explaining how connection pooling is built, and I immediately also got into let's use some queuing there. So
the connection pool is, less a queue.
yeah, it is.
I think, yeah. So, so understanding caches, understanding queues. I think for me, like after all this year, like the two most important data structure is cache and queue.
Mm,
And you can combining cache and queue, you can build production grade systems. Uh, understand the operating system, yeah, and especially from the like perspective, like how the scheduling of processes work, how the operations, mm, IO operations work. I hope there will be someday like book operating system and hardwares for high-level programmers. Because if you look for these topics, the books go really down deep to like, beat level discussions. But sometimes you need like really good models. If you are programmers, really good model how things work.
hmm
Explain in like high level Spring developer language. Because you
hmm
explain these things
Yeah.
in much simpler language. Like there is this, I send you the link, this article, uh, how memory works
hmm
for programmers. And I think we should have like how CPU works for programmers, how storage works for programmers. So like 16 pages, maximum 16 pages to help you understand. Mm. And this is when you explore all these layers, like operating system, your runtime, then it's really good to like focus on tooling. Yeah. Understand how profilers works. All these things like load generators, so Gatling, JMeter, K6S, yeah.
hmm
Uh,
Yes.
whatever you choose, as long as you understand how it works, it's good. It's not like Gatling is better than JMeter, JMeter is better than the Gatling. Just choose the tool and understand how it works. And what I was doing for some time, like when I was learning benchmarking at the level of like single function, don't laugh, I was writing benchmarks to the data structures in Java. So I wrote benchmarks like comparing linked list versus array list, hash
hmm
map versus, the concurrent hash map, and so on, so on. So I was benchmarking code that already exists and trying to like understand, okay, if I got different um, numbers for linked list and array list, why? Yeah.
hmm
And then you say, okay, to answer the why, you need to look at tools. Which tools? Because this is CPU specific benchmark, you need to take a look at the CPU specific tooling. So probably frame graphs and so on. Yeah. So I would start first from understanding, then tooling, and then start writing, things to existing code benchmarks
Hmm.
um, and trying to understand why some things in your standard libraries are faster or slower.
Yeah, yeah, that's a good advice. I really like it. Um, and let's say that so if it, it's it's not surprising that you are good in giving advices. So I ask for one more. uh, because like if you're doing regular testing like unit testing integration acceptance etc., so the graduation is kind of similar to also perf testing, and some people are saying like you should be doing unit first, test driven development, and someone is saying no, 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 you should start from acceptance tests, because if you do too many unit tests, then it will like cement your whole code and architecture, and it's better to first set up the main rules, let's say, for or the baseline for our behavior in our system. Then in terms of perf tests, what would be your advice? Or do you think that you can give like whether to start from high level, so maybe load testing, or maybe be more precise and try maybe not micro benchmarking, because we already said that you it's not so easy, but those single-threaded, focused tests, what would be your advice on that?
I think I would start from like high level end-to-end test and then use regressions. Like for example, if you find regression and you identify that this code path was the reason for regression, then say, okay, I will write specific benchmark for
Mm.
this specific, because we know this code already regressed. You can put some criteria, for example, like, okay,
Hmm.
if it regresses 3 times over like, 6 months, it means, okay, there's a lot of changes probably going in this code. People are constantly changing, or the requirements are changing, whatever reason for changes. So then you use this high-level tests to say, okay, which things need to be covered with
Mm.
benchmarks, like more specific. So I would go from like top level end to end because they will give you like
Yeah.
better safety net. Yeah,
Yeah, that makes sense because he already gives you the hints on what
yeah.
to focus and without spending too much time. And we all know that performance is not a priority unless it starts to be a priority.
I think performance and security are sisters.
Yeah.
It's nobody cares about security until there is a breach, and nobody cares about performance until there is like spectacular disaster. So
Mm. So let's say that someone would like to be like build a performance friendly system or performance aware culture, whatever we uh, hype term we try to invent. Then I will try to maybe recap or rephrase what you said about your way in Neo4j, and maybe could you then say, do you agree or where do you disagree with that? Is it
yeah,
okay? Yes, because let's say that we are building like a regular system and we would like to know, let's say we know that maybe performance is not ultimately critical, but it is really important in our case. And so someone could start with either going up to down. So starting with load testing and setting up the environment, and for that they would need to properly and carefully select the deployment and tooling to get like a predictable benchmarks. So for instance, use EC2 or some other environment where we can have more control on the setup and more, let's say, being more sure that we have a proper isolation of, so no one is impacting or the noise or is less than typically. So for network, disk, etc. And we could start with setting up such an environment for the general needs, and also ensuring that we are having all the metrics, telemetry, etc., because we want to have it as close as possible to the traditional way. Or we can start as you're doing with those single threaded, let's say. Then maybe, for instance, the idea could be that we could run some benchmark for our important database queries, because
Hmm.
most of the systems are query query heavy. So maybe those queries, and then gather those benchmarks and then use them as some sort of comparison whether we didn't make that wrong. And somewhere in between, it would be great to start gathering those this either this traffic, or maybe trying to find whether there is like a common or some written type of traffic. I think that for some domain it should be doable, like popular, like e-commerce. Maybe you can
Hmm.
find some sample. We even had guest in Architecture Weekly, Michael Dragalis. He built like a shadow traffic, which is a tool that allows to simulate like a real also traffic, uh, and understanding the difference between latency and throughput. Like, for instance, one guy asked me that why is when I was working at Event Store, then he said like, why is it Event Store allowing me to only have 20 records per second? And I'm like, okay, that sounds weird, like database with only 200 requests per second. And it appeared that his measurements were correct, but he was only running that in a single threaded mode. So from the single benchmark. So he didn't even try to run in parallel like a multiple workers. And when I did the same benchmarks, then but with a multiple workers, then the numbers were much more positive. So over a few thousands of requests. So do you think that this type of mm, approaching and trying to make our performance in a regular system, would it be like a sane way, or would you change something to that, what I said?
I think uh, it's like if you have already existing system and you develop something, it's used by customer. I would use this data to build your load tests.
Mm-hmm,
I wouldn't do with like fancy finding, what is my blah blah blah
mm-hmm,
important functionality because the customer will tell you what is
yeah,
important. Uh, and but if you start like, okay, you're building something and you are like, okay, we don't have real traffic. We'll have customers in 6 months, and but we don't want to have dramatic performance. Then you need to do some bets. It's like what you said, saying, okay, we assume, we think, according to our research, according to our product owners, that this will be important thing. Then I would not go from top level. I would go from like bottom up,
mm-hmm,
in case of the new system uh, and say, okay, I do a bet that this functionality will be critical. If it's slow, we will not sell the system, for example, uh, because search will be slow. So and the search is like the critical functionality. Then I will start by covering the search and worry about everything else later. Yeah.
yeah, yeah, that makes sense, that makes sense. Okay, so I think that you already gave a lot of really practical hints and suggestions. I also will add those all the links that you send me, and if you add more, then of course I will also add them below the recording. So for the final words, what would you like to say to your uh, fellow developers and software engineers about the performance?
Yeah, I probably you noticed I kind of obsessed with this idea that we are guilty of the climate change. Uh, because of writing slow code. But and then I realized in the beginning of this year that there is like this green coding initiative
Hmm.
somewhat going on. So yeah, so I would say write fast code, please. Really, for two things. It's fun, and second, it will save us some energy and few trees.
Mm.
So yeah, that's my please write fast code. That's
Okay.
fast, fast,
So fast or fast enough?
fast enough. It's like good enough is fast enough.
Yeah, yeah, yeah. I take it. I take it. Okay, so thank you, Jarek. It was a
Thank you.
pleasure. I'm glad that you agreed to join the webinar because I did my humble uh, benchmarking intro, but I'm definitely far from being an expert. And I think that you are the closest to expert of all the people that I know. So yeah, you are an expert actually. So so thank you a lot.
Thank you. Thank you very much for the invitation. It was
Yeah.
fun.
Cheers, folk.
Cheers.